This video covers section 11.6, which is more on probability, specifically in events involving not and or and something called odds. So let's talk about the probability of an event not occurring. Let's just say there is a 30% chance it will rain today. Well, that's 30% chance it will rain. What is the probability it will not rain? Well, to figure out the not, it's a matter of subtracting from 100%, which would be 70%. Or if there is a 1 in 3 chance you will pass the test, what is the chance you will not pass the test? 2/3. So the idea of an event not occurring is this. The probability that an event E will not occur is equal to 1 minus the probability that it will occur. So that's why I got 2/3, because 1 minus 1/3 is 2/3. And of course for percents I was thinking about it being 100%. But I could have done 1 minus the decimal 0.3, which gives us the decimal 0.7, which is equal to 70%. So there's two little formulas here. The probability of not E is 1 minus the probability of E. Or from the other standpoint, the probability of E is 1 minus the probability of not E. So if I had said the probability that it will not rain is 3/4, this is not rain is 3/4, then the probability that it will rain is 1 minus 3/4, which is 1/4. This only works with probabilities where there's only two possibilities, pass or fail, will rain or not rain. So if you were dealt one card from a standard 52 card deck, find the probability that you are not dealt a diamond. Well, not dealt a diamond should be 1 minus the probability that you do get a diamond. Do you remember from the previous video how many diamonds there are? There are 13 diamonds out of 52 cards. So we're not getting that diamond. So this is 1 minus 13 over 52. You can type this into your calculator or get yourself a common denominator here. And this is 39 over 52, which reduces by 13 to give me 3/4. Now I could have reduced right here first and done 1 minus 1/4, which is also 3/4. So you can reduce in the middle or you can reduce at the end. If you are dealt one card from a standard 52 deck, find the probability that you are not dealt a queen. So not getting a queen is 1 minus getting a queen. How many queens are there? There are 4 queens out of 52. So 1 minus 4 over 52 is 48 over 52, which reduces by 4 to give you 12 over 13. Here's a little quickie idea about common denominator if your calculator does not do fractions for you, but if you have a scientific calculator, it will do fractions. If you're going to do 1 minus 4 over 52, you need a common denominator, and that denominator must be 52. So this is 1 over 1. What do you need to multiply 1 by to make it 52? Well, 52. And I must multiply on the top. So look what I have. 1 is the same as 52 over 52 minus 4 over 52, and that's how I get my 48 over 52. Now a totally different way to think about this is the probability of not getting a queen is to count up how many non-queens there are in the deck. There are 48 non-queens. So that's another way to go if you're pretty familiar with what's in a deck of cards. Or probabilities. Or probabilities, we have to determine if something is mutually exclusive or not. So mutually exclusive is this. If it is impossible for events A and B to occur simultaneously, the events are said to be mutually exclusive, meaning this. It's impossible for a card to be both a king and a queen. On the other hand, a card can be a king and a heart. So we are talking about these events that are totally mutually exclusive. And all we have to do with these probabilities is add them together. The probability of A or B is the probability of A plus the probability of B. So when you see or, you're going to add the probabilities. Or means to add the probabilities. Address this situation in a couple minutes, but let's look at a couple examples here. So we got a card selected randomly from a deck of cards. What is the probability of selecting a king or a queen? The probability of getting a king all by itself is 4 over 52. The probability of getting that queen is 4 over 52. Or means to add, and that gives us 8 over 52, which will reduce by 4 to give me 2/13. We can look at OR problems with a die. If you roll a single 6-sided die, what is the probability of getting a 4 or a 5? Now remember, the sample space on a die is 1, 2, 3, 4, 5, 6. What's the chance you'll get a 4? 1 out of 6. What's the chance you'll get a 5? 1 out of 6. They are mutually exclusive. There's no way the die rolls up and it shows a 4 and a 5 at the same time. Add these together, gives me 2 over 6, which gives me 1/3. And keep in mind, when you are adding fractions, they must have a common denominator, and these do. So when you add fractions with a common denominator, you keep the denominator and you add the numerators together. That's how we get 2 over 6, and it reduces to 1/3. Now, here's the possibility, is that these events are not mutually exclusive, like this, the probability of getting a king or a heart. There's some overlap there because there is a card that is a king and at the same time it's a heart. That's why this is not a mutually exclusive event. And the formula for not mutually exclusive is probability of A plus the probability of B, but we must subtract the probability of A and B. And what is this really doing? You are subtracting the overlap. You are subtracting that card or cards that you have counted twice. So probability of king or heart, how many kings are there? There are 4 kings out of 52. What's the probability there's a heart? 13 out of 52. And for OR, we would add those together. But the problem with stopping here is you have counted the king of hearts as a king, and you've also counted it as a heart. So we need to subtract away the king of hearts. We have the common denominator of 52. We keep that denominator and just add up the numerators. 4 plus 13 is 17, minus 1 is 16, and that will reduce by 4, which gives me 4 over 13. You only have to do this subtracting part if the events are not mutually exclusive. In other words, if there is an overlap, you must subtract away that overlap. So in a group of 50 students, we've taken this survey. 23 take math, 11 take history, and 7 take both. If one student is selected at random, find the probability that the student takes math or history. Well, is this mutually exclusive? It is not, because we have this category of 7 taking both. There are some students that are counted in the math students. There are some students who are also counted in the history students. So we must use this formula up here. The probability of math or history is the probability of math, which is 23 out of 50, because they told me there were 50 students, plus the probability of taking history, which is 11 out of 50. But we must subtract away the students that take both. So this is 34 minus 7 is 27 over 50, and that is your answer because it does not reduce. Now, something called odds. I'm sure you've heard about betting odds. There's really 2 different types of odds. There's odds in favor and there's odds against. The formula for odds in favor is this right here. It's the probability of E over the probability of not E. The odds against are exactly the opposite. You just reverse it. It's upside down. It's the not E over this. What I think about is with odds in favor is this is the ways I can win compared to the number of ways I can lose. The odds against are the number of ways I can lose over the number of ways I can win. Now, odds answers can be in the form of a fraction or in words, or you use a colon, but whatever way it's displayed, you actually say 2. You don't say 2 over 3, you say 2 to 3. With the colon, you say 2 to 3, and obviously with the word 2, you say 2 to 3. So a single die is rolled. Find the odds in favor of rolling a number less than 4. Well, I think it's a good idea for us to write out our sample space, so that's right in front of us. Find the odds in favor of rolling a number less than 4. These are the numbers that are less than 4. So think about this being a game. How many ways can you win? You can win if you roll a 1, a 2, or a 3. So that's 3 ways to win. Then how many ways are there to lose? Well, it's these guys over here. There's 3 of those. So odds get reduced also, reduced by 3, and we get a 1-to-1 odds in favor. Because this is in favor, I did win versus lose. This also sets odds in favor, so I'm looking at ways to win versus ways to lose, of drawing a king from a standard deck of cards. How many kings are there? There are 4 cards that are kings. You would win if you drew any of the 4 kings. If 4 of those cards are winners, how many cards are left to be losers? Well, there are 52 cards. Take away the 4 that are winners, leaves 48 that are loser cards. Reduce that to 1 to 12. Could be that your homework is going to ask you to write it as the fraction 1 over 12. What are the odds against getting that king? Well, you've already done the odds in favor. The odds against are just a matter of doing the reciprocal. So it's either 12 over 1 this way or 12 to 1 with the colon. What you enter depends on what your homework asks you to enter. Sometimes you're going to have problems that you know the odds, but you don't know the probability. But there's a very easy way to figure out the probability if you are given the odds. If the odds in favor, got to have it in favor, of an event E are A to B, which is A over B, then the probability of the event is given by this formula. Now look what that is. The probability of the event, the A that was on top of the fraction stays on top of the fraction. And what did the bottom become? The bottom became the B, which was already there, plus A, which was the top. So the way I think about it is this. It's just the top number that you had in the odds over the sum of the top plus the bottom. So if you had this odds in favor, then all you have to do is keep the top the same, add those up. 2 plus 3 is 5. So this is the odds in favor, and this is the probability. So the odds in favor of drawing a king is 1 to 12. That's 1 over 12. Find the probability of drawing a king. Well, A is the top number is 1. B is the bottom number, which is 12. And our formula says keep the top what it was and just add those two numbers together. So you can think of the formula written out with the A's and B's. I just think about it in fraction form like this. So if I have the odds in favor, it's got to be odds in favor. If you have the odds in favor is, let's say, 4 to 7, which as a fraction would be 4 over 7, then all you have to do is rewrite a new fraction which keeps the top the same and just adds those together. So odds in favor of 4 to 7 is a probability of 4 out of 11.